Solving session of this paper 1 multiple choice question of May-June 2023. Okay, so in the part 1 I've discussed the first 20 questions of this paper, and in this video I'm going to discuss the rest of the 20 questions. The 21st question is: the graph shows the variation with time of displacement of a particle in a progressive wave. Two measurements x and y are labeled on the graph. What do x and y represent? So we know this is a displacement time graph. So in a displacement time graph, this x is representing the maximum displacement of the particle, which is the amplitude, okay? And y is the time taken for one wave, which is called the period. So for this question, option A would be the correct answer, amplitude and the period. Question number 22. A car travels at a constant speed along a straight line PQ. A loudspeaker attached to the car emits a sound of constant frequency F. A stationary observer is at a point O. What does the observer hear as the car moves from P towards Q? So from this P to Q. So this is a case of Doppler effect, and we know that as there is a relative motion of the observer or the source, there is a variation in the frequency received by the observer, right? So this is the source here, and let me show you a video of what is the Doppler effect. So here this is the source, and here is this is the observer, okay? So here, initially the source is emitting a constant frequency of waves, okay? As I'm increasing the source speed, what happens? This is a constant frequency emitted by the source, and this observer is also receiving a particular amount of frequency. But as it is moving, you could see this side, the frequency or the waves are compressed, creating a high frequency region at this place, and to the opposite there will be a low frequency region. So the waves is compressed, creating a high frequency, right? So here you can consider the similar case, okay, for the question, this one. So as it is reaches, the frequency is decreasing, the frequency received by the observer is decreasing, okay? So the frequency is always greater than the frequency of this source. So in this options, out of this, option C or D would be the answer, because the frequency will be more than the F, the constant frequency emitted by the car. But whether it will be decreasing or increasing as it is moving from point P to Q. So obviously the frequency will be decreasing, right? Then after that it will be receiving only low frequencies, okay? So the option C is the correct answer for this question. Then question number 23. Some sources of electromagnetic waves in free space are listed. A radio wave transmitter, a source of X-rays, a 30 millimeter wavelength radar transmitter, a light emitting diode that emits a red light. So there is a radio wave and X-rays, and there is another radio wave and a red light, which is a part of visible spectrum, okay, visible light. Which list gives the sources in order of increasing wavelength from left to right of the waves emitted by the sources? So on the left side we need a high frequency wave, and on the right side we need a low frequency wave, okay? So we know the electromagnetic spectra, and out of this the high frequency wave or the low wavelength wave is X-ray, okay? So in this four options for this electromagnetic waves given, the X-rays is having the high frequency or the low wavelength. So 2 would be on the left side. So either B or C would be the answer. Okay, and the next one, do we have ultraviolet? No, but we have visible lights, the fourth option, right? So fourth one will be the next one. Okay, 2, and then the more wavelength will be for the fourth one. And then we have 2 radio waves, right? But if you could see the wavelength of this, the average wavelength for the radio waves is in units of kilometers. But we have the third option, the wavelength of 30 millimeter, which means that the wavelength is comparatively lesser, right? So 3 would be the second one, and the fourth one will be the 1. Okay, so the option C is the correct answer. 2, 4, 3, 1. The next question number 24. A vertically polarized beam of light is incident normally on a polarizing filter. The transmission axis of the filter is at an angle of 40 degrees to the horizontal. Okay, please be noted, it is vertically polarized, but here the angle is given to the horizontal. What we need to find out is the ratio of amplitude of transmitted beam to the amplitude of incident beam. But we know that from the question, it is a case of polarization. In a case of polarization, we must have learned Malu's law, which will give you the intensity of the transmitted beam in terms of intensity of the incident beam. Okay, so here please be noted, this theta is the angle between the transmission axis and the plane of polarization. Here this angle is the angle between the transmission axis and the horizontal, but this is vertically polarized, which means that we need to find out this angle, not 40. Okay, you know that this horizontal and vertical is at an angle of 90 degree, so that this angle would be 90 minus 40, which means that 50 degree. Okay, so here we can substitute theta as 50, but we need the ratio, right? So we can rearrange the formula to find out the ratio of intensities, which would be equal to cos square theta, or that is equal to cos square 50. Please do the calculation and find out. Cos 50 is 0.64 and the square of this is 0.41. Okay, so 0.41 is the ratio of the intensities, but this is not our answer because we need to convert into amplitudes, right? We know that the intensity is always proportional to the square of the amplitude, right? So here we can change this intensity in terms of amplitude. So intensity would be proportional to the square of its amplitude for both the cases, right? Or you can rearrange this as like this: amplitude of the transmitted wave and amplitude of the incident wave square ratio. Square of this ratio would be equal to 0.41, right? So we will be getting the ratio as root of 0.41. So root of 0.41 is 0.64, which means that the option C is the correct answer for this question. Then the next one, question number 25. Two progressive waves meet at a point. Which condition must be met for superposition of the waves to occur? We can check each option. The first option is the waves must be coherent. It is not a necessary condition because if the waves are coherent, we will be getting an interference phenomena. Okay, here they are just asking for the superposition. Then the second option, option B, is the waves must be of the same time. Yes, that must be true because if you are having two coherent waves, okay, no, not it could the same type, which means that it will be coherent. we can consider one water wave and one sound wave. If these two are present at the same point, there won't be any superposition happening because these two are different type. Okay, so for the superposition to happen, they must be of the same type. Okay, so the option B is the correct answer. Question number 26 is, a string is stretched between a vibration generator and a fixed point. When the vibration generator is vibrating at a frequency f, a stationary wave with 5 notes is created on the stretched string as shown. So 5 notes, which means that we have 4 of wavelength. So this is one full wavelength, but we have half wavelength, right? So like this, we have 4 half wavelength in this 5 note. Okay, there is a node at the end of the string that is attached to the vibration generator. The frequency of the vibration generator is slowly increased. So the frequency is increasing. Okay, what is the next frequency that produces a stationary wave in the string? So to do this question, we can split the question into two conditions. Okay, first one, which is having 4 half wavelength. Okay, 4 half wavelength, which means that if you are considering this length of this whole stretched string as L, in this L length we have 4 half wavelength. Okay, so we can rearrange to find out the wavelength in the first condition. We can term it as lambda 1, which will be equal to 2L over 4. So we'll be getting, it will be half of this length. Okay, lambda by 2. Then we can change into the second condition. Now the frequency is increased. Okay, as the frequency is increased, the wavelength also be increased because the wave speed stays the same. Okay, so the wavelength will get increased. At this condition, we will be having 5 half wavelengths. Okay, one more wavelength would be here as the stationary waves is formed. Okay, so in this whole length we'll be having 5 half wavelengths, and we can rearrange to find out the second wavelength, which will be equal to 2L over 5. Okay, so now we have the 2 wavelength, and we can make use of this condition that the wave speed stays the same. Wave speed at the first condition is termed as V1 and the second condition as V2. Okay, and the wave speed formula is frequency multiplied by wavelength. So we can change it into F1 lambda 1 is equal to F2 lambda 2. What we need to find out? We need to find out F2, right? So F2 would be equal to F1 lambda 1 divided by lambda 2. Okay, here we can substitute for lambda 1 and lambda 2 and F1 as F. So lambda 1 is L over 2, F1 is F, and lambda 2 will be 2L divided by F, so it will be multiplied by F. L and L will get cancelled and it will be 5 by 4 F. So if you're doing this calculation, 5 by 4 is 1.25 F. Okay, so this would be the frequency after increasing the frequency. Okay, so option A is the correct answer for this question. Question number 27. A ripple tank and a barrier with a single gap are used to demonstrate the diffraction of surface ripples on water. Initially, the wavelength of the ripples is 5 times smaller than the gap in the barrier, which change increases the amount of diffraction observed. To obtain the maximum amount of diffraction, the condition is that the wavelength must be having the same size as the gap. Okay, these two must be like similar. then the amount of diffraction would be maxima. Okay, so we can check the first option. Option A is double the amplitude of the ripples. It's not going to change the diffraction. The amplitude doesn't have any effect on this amount of diffraction, so option A is wrong. Then option B, double the width of the gap. No, if you are increasing this width, it won't be equal to the gap, wavelength, right? This length is really smaller than this length. We need these two almost the same length. So this is also wrong. Option C is half the frequency of the ripples. Okay, if you are decreasing the frequency, that will increase the wavelength. So as you are increasing the wavelength, it might be equal to the gap size. It will be almost the same. So you can half the frequency. And option D is half the wavelength of ripples. It is again making these two not the same. Okay, so option C is the correct answer for this question. So you could see that as the gap size is the same, the amount of diffraction, which means that the spreading of the wavelength waves is more. Question number 28. A laser produces a beam of light of wavelength 650 nanometer. The beam is incident normally on two slits that are at a distance of 0.12 millimeter apart. A screen is placed parallel to the slits. The bright interference fringes on the screen have a separation of 7.5 centimeter. What is the distance between the screen and the two slits? So this is a case of double slit interference, right? So this is a monochromatic source, light source, and here is two slit. Let us suppose this slit separation is A, and we have a bright fringe over here, and over here. Okay, the separation between the fringes is considered as X, and the distance between the screen and the double slit as capital letter D. Okay, so we can use the formula lambda is equal to AX over D to find out the wavelength. We have the wavelength, A value, X value. What we need to find out the D value. Okay, so we can rearrange as AX divided by lambda and just substitute the terms. So A is the slit separation. The slit separation is given as 0.12 millimeter, which means that 10 to the power minus 3 meter. Okay, multiplied by X is the fringe separation. Okay, fringe separation is given as 7.5 centimeter, which means that 7.5 multiplied by 10 to the power minus 2 meter divided by the wavelength. Wavelength is 650 nanometer, that is 10 to the power minus 9. So if you are doing the calculation, you will be getting a value of 13.8 meter, which is almost equal to 14 meter. Okay, so option D is the correct answer for this question. Question number 29. A beam of light from a laser is incident normally on a diffraction grating. The diagram shows only the second order maxima that are produced. Okay, the grating has a line spacing of 1.0 times 10 to the power minus 6 meter. The angle between the second order maxima is 110 degree. What is the wavelength of the light? So this would be the structure for this screen. Okay, the screen will be having a central maxima, first maxima, second maxima, third maxima, as so on. So the first maximas on either side of the central maxima is considered as the first maxima. Okay, here we have the second maximas. Okay, this angle between the second maximas is given as 110. Okay, what we have is the formula for the diffraction grating, that is n lambda is equal to d sine theta. The theta value is the angle between the central maxima and the order of this maxima. Here it is the second maxima. This is the theta value that we need to consider, which is half of 110, which is 55 degree. The n value would be second order, so it will be 2, and d value is 1.0 times 10 to the power minus 6 meter, and the theta is 55. You need to substitute these values in this, so we can rearrange the formula as d sine theta over n and substitute and find out. You will be getting a value of 4.1 times 10 to the power minus 7 meter. Okay, so option A is the correct answer for this question. Question number 30. The electric current in a metal wire is 4.0 milliampere. How many electrons pass a fixed point in the wire in a time of 10 hours? Okay, so the current is given. You know the current formula, that is Q over T. How many charges is flowing in unit time? Okay, and the charges is having a formula like Ne. It is always, there is always a quantization of charges. So N is the number of electrons present and Ne is the charge of an electron, okay, divided by T. What you need to find out? The number of electrons, right? Please rearrange the formula to find out N. Then the formula will be changed into I times T over E. So the current here is 4 times 10 to the power minus 3 amperes times 10 hours will be 10 times 60 divided by the charge of an electron, which is 1.6 times 10 to the power minus 19. So if you're doing the calculation, you will be getting a value of 9 times 10 to the power 20, which means that for this 30 question option C is the correct answer. Question number 31. What is the definition of the potential difference across an electric component? This must be really familiar. That is, the amount of energy transfer per charge is what we call the potential difference, which means that directly it is the option B, the correct one. Question number 32. Which graph shows the IV characteristics of a filament lamp? We can check each option. Option A, which is showing a IV characteristics for a diode, which means that in the case of filament lamp, it is a non-ohmic component. Okay, so initially it will be obeying the Ohm's law, and then eventually the resistance will be increasing. That's the condition for the filament lamp. Here the component is not even passing the current till it is attained a particular potential difference, okay, which means that this is for a diode. Then the second option, here this is a straight line, which means that it is always obeying the Ohm's law, or it is having a fixed resistance value. So this is also a wrong option. So option C, here you could consider the gradient. Okay, so gradient for this graph is current divided by voltage. We know from Ohm's law that V is equal to IR, which means that V over I is the resistance value. Okay, here we have the reciprocal of this, which means that reciprocal of R is showing the gradient. So in this option C, if you're considering the initial condition, it is increasing. The current value is increases as the voltage is increased, but eventually the gradient is increases, right? The gradient is increases, which means that the resistance is decreases. That's not true for the filament lamp, which means that the option C is wrong. Option D, as the voltage is increases, the gradient is decreases, which means that the resistance is increases, which is a condition for filament lamp. For the question 32, option D is the correct answer. Next is Question number 33. A metal wire has a length of 2.50 meter and a cross-sectional area of 4.50 times 10 to the power minus 6 meter square. The resistivity of the metal is 3.50 times 10 to the power minus 7 ohm meter. The wire is stretched so that its length increases to 2.65 meter. The wire remains cylindrical and the volume of the wire remains constant. Okay, this point to be noted. What is the change in the resistance of the wire? So here you need to find out the resistance. In the case of resistivity, you can use the formula R is equal to rho L over A. So whether it is it is structured or it is compressed doesn't matter. This resistivity stays the same, as the resistivity is a property of the material. Okay. So for the first condition, we can term it as R1. We can find out the R1 value, right? The resistivity is 3.50 times 10 to the power minus 7, and the length, the first length is 2.50, and the area of cross section is 4.50 times 10 to the power minus 6. Okay, please do the calculation and find out the first resistance value. So this value would be 0.194 ohms. Okay, and then we are changing this length L1 to L2. So this is a second condition, and the L2 is given as 2.65 meter. So since the wire is a cylindrical, you know that the volume is equal to the length multiplied by the area of cross section. As the volume stays the same, V1 is equal to V2. The length in the first condition we can write as L1 times A1, that is equal to the volume after structure L2 times A2. You know L1, A1 value and L2 value also. What you need to find out is A2, right? So please rearrange. You will be getting L1 times A1 divided by L2. Substitute those values, that is 2.5 times 4.5 times 10 to the power minus 6 divided by 2.65. So the area cross section you will be getting as 4.24 times 10 to the power minus 6 meter square. Okay, so now you have the area of cross section too. So for the second condition you can find out the R value by substituting, right? So the resistivity value is 3.50 times 10 to the power minus 7, and the length is now 2.65, and the area of cross section that you calculated is 4.24 times 10 to the power minus 6. So the resistance value would be 0.21 ohms. Okay, so these are the resistance value in each cases, and what you need to find out the change in the resistance, right? Which means that R2 minus R1, which is equal to 0.21 minus 0.19, which is equal to 0.028 approximately. Which option is closer to this? Option B, which means that for this question number 33, option B is the correct answer. Question number 34. Which circuit symbol represents microphone? So the first option is representing the circuit symbol for the electric bell, and option B is for the buzzer, and option C is the microphone, and option D is loudspeaker. So option C is the correct answer. Question number 35. A battery with internal resistance is connected to a fixed resistor, an ammeter and a voltmeter as shown. The battery is replaced by a different battery that has the same electromotive force EMF but a greater internal resistance. What happens to the reading on the ammeter and voltmeter? You know that how EMF value and the voltage is related. E is equal to V plus IR. Here the R is representing the internal resistance value. Okay, so here first you can find out what is the change in the current value. So for that we can rearrange this formula as I is equal to E minus V over R. So from this you could find that as the internal resistance increases, the current value decreases, right? So as the current flowing through the circuit is decreases, the ammeter reading also be decreases. So it will be either A or B, the correct answer. Okay, then what about the voltage reading? So voltage across this resistors, right? V is equal to IR. So as the I value is decreases and R here is a fixed resistors, right? R, which is a constant, V value will be decreases, which means that option A is the correct answer. Question number 36. 4 potential divider circuits each consist of a battery of electromotive force of 9 voltage and negligible internal resistance connected to a combination of resistors. Each of the resistors in the circuit has a resistance of X or 2X. Which circuit has the largest output voltage V? So to find out the voltage, okay, in a potential divider, if I wanted to find out, I have R1 and R2 which is connected in series, and I have to find out the voltage across V and the EMF value, the voltage given to the whole circuit. If it is V1, which is the voltage across R1, can be calculated as R1 divided by R1 plus R2 multiplied by V. Okay, this is a general formula. We can find out for each cases. For the option A, the voltage V, this will be S, the resistance, divided by the sum of the resistance, X plus X, these two, multiplied by the voltage given, 9. So you'll be getting 9x divided by 2x. X and X will get cancelled. 9 by 2 is 4.5 voltage. So here the voltage value is 4.5. And here option B, the resistance is 2x divided by the combination is 2x plus x, and the voltage given is 9, which means that 9 times 2x divided by 3x. So X and X will get cancelled, and 9 times 2 is 18, and 18 divided by 3 is 6, which means that 6 voltage. So comparatively option B is having the higher voltage. So if you are checking the option C, you could see that this value, the voltage across the R1 resistors is proportional to the R1 value, right? If the R1 is more, the voltage will be more. But here you could see that this is a combination, a parallel combination of resistors, X and 2X. So in a parallel combination, the total resistance would be lesser than each of these resistors, right? Which means that even if you are calculating the voltage across this terminal, you will be getting a value lesser than these two. Okay, and in the case of D also, this combination resistance is more, as 2x is here, which means that this value is more, so the voltage would be less. So option D is also wrong. So the correct answer for this question is option B. Question number 37. A voltmeter is connected into a circuit with the polarity shown. The sliding contact is moved to end P of the potentiometer and then to end Q. What are the two readings of the voltmeter? In this case, we can make use of the Kirchhoff's voltage law. What we know is the total voltage would be, or sum of the voltage would be 0. Sum of the EMF would be equal to sum of the potential differences. Okay, so in the first case, it is connected to the terminal P. So this is the closed circuit now. So we can consider the charges flowing from this P position to the anticlockwise direction. So 3 we can take it as positive, and this negative terminal is connected to the negative terminal of the voltmeter, which means that the voltage reading on this voltmeter will be a negative 3 voltage minus V, and the sum of the voltage is 0, right? Which means that V is equal to 3 voltage. So at point at the sliding contact P, the voltage will be 3. So either option C or D would be the correct one. Then we can check for the end Q as well. So if it is connected over here, now this is the complete circuit, right? So here if you are considering the movement from this position or from this position, wherever, the voltage will be the summation of EMF will be 3 voltage, this one and this one, plus 3 voltage, right? And here this is negative oppositely connected, so minus V, which is equal to 0, which means that 6V minus V is equal to 0, 6 voltage, right? Which means we will be getting V as 6 voltage. So the voltage, if it is connected at end Q, will be 6 voltage, which means that option D is the correct answer for this question. Question number 38. A proton has a mass MP and charge plus E. What are the mass and charge of an antiproton? So in the case of antimatter, it will be having the same mass, but the charge will be the opposite, which means that same mass will be option C or D. And let's check for the charges. The charge over here is plus E, so it must be of the opposite charge, which means that minus E. So the option D is the correct answer. Question number 39. A uranium nucleus has 92 protons and 143 neutrons. The nucleus emits a total of 3 alpha particles and 4 beta minus particles to form nucleus X. How can nucleus X be represented? So let's consider the situation. Uranium is having 92 proton and 143 neutron. So what will be the mass number? Mass number will be the sum of proton and the number of neutron, which means that 235, which is emitting 3 alpha particle. Alpha particle is having a mass number of 2 and a proton number of mass number of 4 and a proton number of 2, plus 4 beta minus particle. Beta minus particle is electron, which is having almost a 0 mass number and charge minus 1, plus the element X. Okay, as you know, in this nuclear equation, both proton number and the mass number will be conserved. So we can check for the proton number first. So on the left hand side it is 92, and we can just substitute here as A and the mass number as B. So this 92 must be equal to 2, so 3 times 2 plus 4 times minus 1 here in the second element plus A. Okay, so it will be 92 is equal to 6 minus 4 plus A. So after doing the calculation, you will be getting that A is equal to 90. So option D or option A. Let's check for the mass number 2. That is 235 must be equal to 3 times 4 plus 4 times 0 plus B. So 3 times 4 is 12 plus B is equal to 235. So if you're doing the calculation, you will be getting the B value as 223. So the mass number is 223, and the proton number is 90. So option D is the correct answer. Question number 40. Which statement about a proton is correct? So we know that the fundamental particles is classified into leptons and hadrons. In this hadrons, it will be divided into mesons and baryons. So in the proton is a baryon, okay, so which is composed of 3 quarks. Okay, so we can conclude that this is a baryon. Proton is a baryon and a hadron, right? Not a meson. So which is the correct option? Proton is a baryon and not a meson. So the option A is the correct answer. So by this we have finished all the questions in this paper. I hope this will help you for the exams. All the best.